Hello everyone, welcome back to my channel. This is Jess. So today we'll be looking at another tree question called binary tree level order traversal. This kind of traversal is also called BFS or breadth first search. I talked a little bit about BFS and some of the other traversals in one of my other videos. So if you're interested in that video, I'll link it in the top right corner. So let's first take a look at the problem statement. You're given the root of a binary tree and you're asked to return the level order traversal of its nodes values. In other words, from left to right, level by level. So if we look at this example, if you're given a tree like this and what you want to return is 3 as one list, and then 9, 20 as another list, and then 15 and 7. So that's level by level. So now let's think about how to approach this problem. Since we want to return this binary tree level by level, if we're starting from the root level, that level is pretty simple because there's only this one node, which is the root node. And then for the next level, also pretty simple because those are just going to be the children of your root node. But from that level down, things get a bit trickier because we'll be looking at the children nodes from multiple different nodes. So if you are already on one of those lower levels in this tree and you want to get the other nodes in the same level, then you'll have to traverse back up to a node that is a common ancestor of all the other nodes in that level. And then you have to traverse back down to find all those nodes' children or grandchildren, which makes the runtime very heavy. But another way, if we have the nodes in one level, then it would be very simple to get the next level of that level, because you could basically just go through that list and then get the children nodes of each of the nodes in that level. So the idea of how to approach this problem would be to save the nodes of your next level beforehand. So once you're going through one level, you also want to store the nodes of that level's next level in some list so that once you're done with your current level, you can just take that list and then go to the next level. Another very crucial part to this approach is that we want to return the level order traversal from left to right, meaning that the leftmost node is going to be the first node in that level list. To do that, suppose we have our current level list starting from the leftmost node. Then once we're traversing through this current level list, we could just going from the very beginning, which is the leftmost node, and then get that node's children and then store it in the next level list, and then continue with the rest of the nodes in your current list. And once we get to the next level, we're also going to start from the very beginning of the level list and grab that node, which is the leftmost node of that level, and then keep going. In other words, whenever we're looking at a level list, what we want to do is to get the node that's first inserted into that list. So what's the data structure that does that? A queue. That's right. A queue would be a data structure that has this first in, first out pattern. So as long as we're inserting the leftmost node of a level into the list or into the queue, when we're dequeuing that level, we'll always get the leftmost node first. So to simplify the whole algorithm a little bit, what we're going to do is to have this queue, we can name it the current queue, and then we're going to store our root node at the beginning into this current queue. And then we're going to have a while loop that loops through all the nodes in your current queue. And in this loop, every time when you dequeue a node from that current queue, you want to get that node's children, if it has any, and then store it into a next level queue. And once you've traversed through all the nodes in your current level queue, you're going to copy the nodes in your next level queue into your current level queue and then repeat the while loop until you're on the leaf level, which is the bottom level of the tree, and then you're done with the traversal. So now let's take a look at how to implement this approach. First thing first, we want to check if the given input is valid. So if not root, then we just return an empty list. And then we're creating our current level queue. We're using a list to represent it. And we're going to pass in our root node to begin with. And then we'll also be creating our next level queue, and we'll initialize it to an empty list. And then we'll have our result list that stores the result, and we're creating this current level list. I know it's a pretty long name, but this list holds all the node values from the current level. And now let's start our while loop. So while current level, so this checks if there's still anything that's in the current level, which in the very beginning, it's true. So while current level is not empty, we're going to get the node of the current level. So the first node. So we're going to do current level dot pop. And we're going to put the value of this node into our current level list. So current level list dot append node dot val. And then we need to check if this node has any children. If it does, we then put it in our next level list. So if node.left, meaning if the left child of the node is valid or is not null, we then append it into our next level. Same thing for the right child. Node.right. And then say if this node is the last element in our current level, then what we need to do, so first we check if current level. So basically, if the node is the last element, and once you pop that out from the current level should be empty. So if current level is empty, then we need to copy all the things from our next level into our current level, meaning that we're moving to the next level. And we need to reinitialize our next level to be an empty list so that in the next level, we still have a clean next level list to store the level after that. And then we want to append our current level list into our result list. So current level list, again, it holds all the node values of your current level. And then also we want to clean this up. So once the while loop is finished, so that's when all the nodes in the tree has been traversed, we just simply return our result list. So now let's take a look at the runtime and the space complexity for this implementation. For our while loop, it essentially is going to loop through all the nodes in the tree, and inside of our while loop, popping from a queue only takes big O of 1 runtime, and appending is also big O of 1 runtime. So overall, the runtime of this implementation is going to be big O of n being the number of nodes in the tree. And for our space complexity, we are storing the nodes in the current level and the next level, and also our nodes value in the result list. So the overall runtime complexity is also going to be big O of n. And that's it for today's video. I hope you enjoy it. Feel free to try this out on LeetCode or on your own, and feel free to post any comments, questions in the comment section, and I will see you in my next video. Bye!